Hi, this is Mr. Erlin. I'm going to do a quick lesson for you today on special segments of triangles and special centers of triangles. We'll begin with some terminology, some vocabulary. First is something called a mid-segment, and it sounds kind of like it is. It's a segment that goes across the middle of a triangle. And what we mean by a middle is that if I were to take a point that's on the middle of this side, in other words, the midpoint, and a point that's on the middle of this side, the midpoint of that side, and then I were to connect them, that would create something called a mid-segment. And a mid-segment has some interesting features about it. We'll discover that it has two features. One is, if this length is x, then the bottom length AC would be exactly twice that, 2x. And we'll discover that this mid-segment is parallel to the side that is not intersecting. See how it's intersecting side AB and it's intersecting side BC. Therefore, it's parallel to the third side, AC. Definition is a segment that joins the midpoints of two sides of a triangle. Second term we need to know about is something called a perpendicular bisector. We've used bisector terms before, and we've used perpendicular term before. So we know these components, but we're putting them together. What we're saying is that a line, segment, or ray that divides a segment into two equal or congruent parts and is perpendicular to the segment. Perpendicular. So for example, if I wanted the side that is perpendicular to AC and through the midpoint, so I'd find the midpoint, suggesting that these two parts are congruent, and this segment is going to be perpendicular to AC. It may or may not go through the point B. We'll discover later it will go through the point B if this is isosceles, but the perpendicular bisector is a bisector of a side and perpendicular to that same side. The third piece we're talking about is called an angle bisector. We've used this concept before. If we wanted an angle bisector of B, for example, what we're saying is it is a ray, but not just any ray, it's the ray that happens to cut this angle exactly in half, so that this angle and this angle are exactly the same. Mine isn't drawn very well. I think it probably should be over here a little bit more to be an angle bisector. It may or may not be perpendicular. It does not have to be. It may or may not cut the bisector. It does not have to be. That's a pretty unique circumstance. It's a line, segment, or ray that divides an angle into two congruent parts. The fourth one is called a median. And a median is a segment that connects a vertex of the triangle, in other words, a corner, A, B, or C, I'm going to go with B, of a triangle to the midpoint of the opposite side. So again, if I were to find this length and find exactly halfway, so that those lengths are the same, when I connect those together, that is a median. Next one is something called an altitude. And if you think about it, when you're talking about what the altitude is of this point B, it wouldn't measure down this face of the mountain or this face of the mountain. Instead, it's almost as if you drop a string with a rock on it and find out exactly how tall it is if you measured straight to the ground. So an altitude means that connects a vertex of a triangle to the opposite side so that it is perpendicular to that side. And again, what we're discovering here is that all these have features that are similar in the sense that here we've got two midpoints connected. Here we've got a midpoint with perpendicular. Here we've got something different, angle bisector. But here we've got a midpoint connected to a vertex. And here we've got a vertex with perpendicular. So they're tied together. They're all very similar, and yet it's going to take some work for you to memorize the individual circumstance. So this is worth putting on flashcards or in Quizlet or something like that for you to memorize. What this is all about is that we're going to find the different centers of a triangle. Turns out that although in concept, what we're saying is if I have a triangle, what is the center of that triangle? Now, if I ask you for the center of a circle, it's easy. You'd say, well, the center of a circle is the point right there, such that every single direction you go off is going to be the same length. They've all got the same radius. That's what the center of a circle means. It's equidistant from all sides, or all points on the circle. If I were to talk about a square, it gets a little bit harder, because I could either take a point that is the same distance from the sides, and again, since we're doing point to a line like we did back when we did the algebra on this in Unit 3, it would be where it's perpendicular. That would mean that these are all the same length away. The center is the equidistant from all sides. Or I could talk about it as being equidistant from all corners or angles. And it turns out that in a square, that'll be the same, right? That point that's equidistant from all corners is also equidistant from all sides. Not the same distance from the sides as from the corners, but that is the center. And if I were to do an equilateral triangle, that would work out as well, where there is a point that exists that is the same distance from each side, and that same point is the same distance from each angle. Okay, in an equilateral triangle, that works out great. But if the triangle is not equilateral, or not all sides are the same, turns out that we end up with different points depending upon which way we look at it. Is it the same distance from each corner? Is it the same distance from each center, or some other choices? That's what these are all about. So the circumcenter is that point at which three, let me just make sure I remember this. Okay, let me do these in the order that I remember, and I'll deductively figure out what the other one is. Incenter is always on the inside, and it's the point at which three angle bisectors intersect a triangle, in a triangle. In other words, I draw the angle bisector from here, and the angle bisector from here, and the angle bisector from there, and it reaches a point in the middle, okay? These little angle things here, these perpendicular measures, are just, they're for something else, but they might confuse you a little bit. The centroid is the coolest one, and that's if you go from the midpoint of the side to the opposite vertex. In other words, creating the median. Where is it? Median there. So if I take the midpoint to the opposite side, that would be a median. And if I go midpoint to this opposite side, that would be a median. And midpoint to this opposite side. Turns out all three of those medians in any triangle will be what's called coincidental. These are coincidental, which means they coincide or they meet at the same point. All three of these meet at the same point, and the point at which they meet is of three medians is called the centroid. If in fact I were to take the altitudes, in other words, going from a base, not necessarily the midpoint, but perpendicular up to the vertex, in other words, how tall that is, and how tall that is, and how tall that is, and I do all three of those, they'll meet at a single point, a point of coincidental, there, a point that is coincidental. And the intersection of those three altitudes makes something called an orthocenter. And the last one, when I take perpendicular bisectors, in other words, it goes through a midpoint and it's perpendicular, midpoint and it's perpendicular, midpoint and it's perpendicular, that will give me something called a circumcenter. Okay, so we have these 4 different types of lines that cut across a triangle. One is a perpendicular bisector, and if you have all 3 perpendicular bisectors, they make a circumcenter. They find a point that is the circumcenter. And what that ends up being is the center of a circle that goes through all vertices. In other words, it's the center of a circle that circumscribes the triangle. The second type of segment is called an angle bisector, and where you split each angle exactly in half. And if you were to do that with an angle bisector, that would create the center of a circle that exactly can be inscribed inside the triangle. It'll fit just inside. This radius is the same as this. In other words, it's equidistant from all sides. And if you were to take the medians of a triangle and do all 3 of them, it creates a point that is the center of gravity. Or balance. In other words, if you picked up this triangle, cut it into cardboard and picked it up and put your finger under it or a pen under it so that it would perfectly balance, that's the spot that would be exactly weighted to balance it. And the last one, if you take the altitudes and you put them together, you create something called the orthocenter that doesn't have a cool application like this. It is part of the 9-point Euler circle, but not as interesting. Okay. Thank you for your attention. Please get these notes done and submit them in Canvas for today. Have a good day.